All right, now it's time for you to tackle making your own line graphs, and we're going to do that by looking at 3 different examples to start with. So let's take a look at a growth chart for Matt's height. We measured Matt's height from the time he was 2 years old to 16, and we measured it in centimeters, so we want to plot this. So before you tackle making a plot, you have to decide which axis is which, what variable goes on which axis. So in this case, age controls height. So that means age is the independent variable and height is the dependent variable. The height depends on the age. So that means the age is the x, or horizontal, and what height is the y, which is the vertical. So I'm going to label my axis right away. So this is age in years and height in centimeters. So the next step is to say, all right, I've got this piece of graph paper and I'm going to count how many squares I have in each direction. So I've already done that for you. There's actually 20 squares in each direction. How do I use those squares? Well, if I'm going to 16, it makes sense to have each square be 1 year. So starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Now we're not going to be using this at the very beginning because there's no information beyond 16. Now the height is a different story, because if I go up in ones, I'm only going to have 20 centimeters and I want to go all the way to 175 centimeters. So the way to tackle this is to say, all right, I want to go from 0 to 175 centimeters, and that's a jump of 175 centimeters, and I have 20 squares to do it. So 175 centimeters divided by 20 squares is 8.75. That means I can make each square 8.75. But 8.75 is a really awkward number to work with. Can you imagine jumping 8.75 each time? So the most convenient number that's close to 8.75 is 10. So I'm going to use 10. 0, 10, 20, 30, 40, 50, 70, 80, 90, 100. And I'm not going to write the rest of them in. I'm just going to jump a little bit, go up 1, 2, 3, 4, 5, and that's 150. And 1, 2, 3, 4, 5, and that's 200. So as long as you put some numbers in, you don't have to put every number on the vertical scale. So now we're going to plot these points, and I'll maybe plot these in a different color. So 240, I had to go find 2 on my x-axis and plot 40, 4 and 60, 6 and 70, 8 and 100, 10 and 120, 12 and 145. So that's 100, 110, 120, 130, 140, 150. So 145 is in between there approximately. At 14, he is 165. So that's 150, 160, 165. And at 16, he reaches 175. That's about right there. The next thing I do is I connect the dots. So there we go. Now 0, 0 is not a point on the graph, so don't force it to go here. Don't connect that point, because at 0 years old he is not 0, centimeters. He was born with some kind of height. We just don't know what it is. We could use the graph to estimate it, but it is not 0, 0. So now let's take a look at the graph that we have made and figure out what the graph is telling us. What does it tell us specifically about the height at 11 years old? Because that's not a point that we were plotting. It was, but something that we can use from the graph. So we find 11, and we draw, I'll go all the way up to the graph, and it looks like his height would be approximately 130 centimeters. This is called interpolation. Fancy word for making an estimate using the given graph. So it looks like Matt is steadily increasing in his height. He's growing steadily, and he's flattening out at the end. Notice that this is a little bit flatter up here, so maybe his growth spurt is slowing down, and that's his adult height. So what does it tell you about what happens at 20 years? Well, we have to take the graph beyond what we've graphed, so outside of the points. This is called extrapolation. This is a fancy word for expanding the graph. So at 20, if we say, all right, Matt is going to continue at the same rate that he did between 14 and 16, it means we can extend the line and say, all right, he's going to be approximately 190 centimeters. Now, what assumptions did we make? Well, we made the assumption that his growth rate is going to be the same. From 16 to 20 as it was from 14 to 16. And that might not be the case. I mean, I know you probably can think of people that grow in spurts. It might be that he flattens out and then takes another growth spurt a little bit later on, and then the answer would be completely different. So when you are asked to extrapolate, you have to think about the assumptions you're making and state those as part of your analysis.